Hello, my name is Sheridan. I'm the circuitry artist, and in this video I'm going to be going over how to properly measure current, voltage, and resistance, just to show you the basics of how to properly measure a component, not just in falstad but also in real life. So we're going to start with resistance, and if, say, for instance, we didn't know the value of this resistor, so oftentimes the values are actually printed in color for a resistor. They use a special color coding band. You can look that up if you would like to. But say that, for instance, we didn't know, or the color got rubbed off and we didn't know the value of a resistor. So if a resistor is in a circuit, in order to measure it, we have to disconnect one end of the resistor before we measure it. Now, unfortunately, in falstad, there is actually no component that will measure resistance because it already tells you. But if you have a meter, you will have to disconnect one end of the component in order to properly measure it. Otherwise, what's going to happen is that, say you've got this circuit right here, your resistor cube, and you try to measure it with the resistor connected to the rest of the cube, you will measure not only the resistor that you want to measure, but also the resistance through the entire rest of the cube. So you won't get an accurate reading that way. So to measure voltage, the reason that you would want to measure voltage is because, trying to cut that out. Okay, so the reason that you would want to measure voltage is because there are certain voltage limits for certain components. So if you're designing a circuit and you're noticing that one component is exceeding its voltage limit, you may want to know how much voltage is being put out there and how much voltage is going across the other components in the circuit so that you can fix your errors. So say, for instance, that we wanted to measure the voltage across this resistor. When you measure voltage, you have to leave it hooked up to the rest of the circuit, otherwise the current won't flow through it, and if there's no current, there's going to be no voltage. So in falstad, there's two ways to measure a voltage. The obvious way, the third and most obvious way is to simply mouse over the component and let falstad tell you what the voltage is. But the source of where it gets that voltage from can be found by taking the difference in voltage between one and the other end of each component. So let me show you what that looks like with the scope probe. We have our outputs. Sometimes they reorganize these menus and it's hard to find things. Here we go. So this is our scope probe. All it is something that'll tell us the voltage between 2 points. So we can just hook that up directly to our resistor. So when you leave one end open of a scope probe, it'll assume that the other end is connected to ground. Ground is 0 volts. So naturally, we're getting 3 volts from this point to ground, not across this resistor. Now if we hook it up, we'll find that we only have 1 volt that's actually going across this resistor. If we, for instance, wanted to measure this other resistor over here, we could simply do the same thing, even though we didn't have to technically hook that up. We could also put a ground symbol on the scope itself. That way, falstad will recognize these 2 points as the exact same point. It's just distributed through the schematic differently. One of the things that we can also do to verify our voltage on a component is to use our test point feature. The test point feature is just a simple point that'll tell you any voltage in reference to ground wherever it's connected. So here we have 2 volts to ground and 3 volts to ground. That makes a difference in the voltage of 1 volt. Simple enough. Now to measure current, you have to break a circuit and then insert your current meter where your break was just made. So in falstad, there isn't a tool for measuring current. However, you can still get the current not just by mousing over a component, but if you wanted to display a current, what you could do is, I've already done it here, I've added a little wire section in series with this resistor. So if I wanted to measure the current that's going through this resistor and continuously display that, I could simply show the current. So now I know that there's 20 milliamps going through this resistor because it's in a straight line with that resistor. If I wanted to find out the current that's going through the whole cube, I could simply break the connection to ground, insert a wire into the break, and then display the current for the wire that I just put in. Sorry, there we go. So now we know we have 60 milliamps going through the entire cube. The other thing is that when you have a single voltage input and a single current input and single current output, you can recall what I said in an earlier video, where when you have current flowing in, you have to have the same amount of current flowing out. So you can see that here, that there's 60 milliamps going into the whole cube, and there's 60 milliamps coming out of the whole cube. There is no current that's being lost anywhere in this cube. So that's all I wanted to cover for today. I hope you will continue to watch these videos, like and subscribe, and don't shock yourself.